So now that we have essentially our contracts all up and ready to go, let's go ahead and use the Truffle console to test to see that we can successfully deploy these contracts, that we can transfer the tokens to the decentral bank over here, and everything is, you know, is good to go. There's not too many, there's no mistakes. Well, not too many. Hopefully there's no mistakes. And let's go ahead and go through all that and review what we've done through this process of setting everything up. Okay, so we're going to go back in the terminal. I'm going to go ahead and make this a bit bigger so you can see. All right, hopefully that's better. Okay, so the first thing we want to do is load up the Truffle console. Cue the elevator music. Do, 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 do. Oh, and we've got some sort of error over here. Cannot connect to your Ethereum client with the following parameters: hosts 127, port 7545. Okay, so I think it's actually because if you noticed, I closed my Ganache, and Ganache is compiling. All right, and here we go. I got a nice fresh slate. So I've got my addresses here. We notice that we have the same port opened up, and we have the same network and the network ID. Great. Okay, so, and this is, if you load up a new instance of Ganache, it still should run on your Truffle console because we're always hooking up to the RPC server, and it's just going to fetch the new address information. Because this is an array of accounts, right? And that's what it will be looking for. And so we can actually further clarify this point if we go back to terminal and I rerun Truffle console. Okay, so now our Truffle development environment is loaded. Looks like we're good to go. It's hooked up to our Ganache. So let's go ahead and run some tests to see that we have successfully deployed our contracts and the new integrations of interacting with them. So what we're going to do is we're going to create an accounts over here, and we're going to set our accounts to web3.eth.getAccounts like this, and we are going to await. Because we need this to run first, so we need JavaScript to wait for us to get the accounts before we can actually get the accounts. Okay, and let's process that. Okay, and so just in case you're still confused about this, essentially we're running Web3, which is accessing the Ganache, and we are getting it from ETH to get our Ganache accounts like this. Okay, and we have 10 accounts over here. So this is an array, meaning that now if I want to verify that our accounts are the correct ones and they're up and loaded, I can just put in accounts like this, create an array, and let's say we want the owner address, so the first account, and there you go. So we see this account ending in the E204FC. Sorry, it's the morning time over here. E204FC, and if I check on Ganache, we see the first account over here is E204FC, right? 100 ETH. Woohoo, we're rich. But, don't get too excited. It's not real ETH, right? This is just tests. And here's another thing. Be careful, just a disclaimer here. Be careful with these accounts. This is for fake ETH transactions only. Don't use these accounts. Be very safe, especially with showing your key over here. This is your private key. You don't want to do that. Show that to other people. So this is just for test environments. And we're doing this for our purposes of learning together. Okay. All right. So we see that we have the account, and we can also show that here we have accounts. We can grab other accounts. If I can spell it, not account, accounts. Not. There we go. There's another account. Okay. So we have this account, let's say the first account, right? And we know that there's 100 ETH, but we know that because we are clicking on Ganesh. Let's say we wanted to verify the balance of using the smart contracts and the functions that we built instead of clicking on Ganesh. All right, because we want it to be working in our code, of course. So how would we do that? Well, what we could do is we can set balance over here, and we can run another await, and we can say, wait, actually, hold on. Before we even do this, we should also grab the smart contract for our tether, right? So let's go ahead and do that and do it like we did it last time. If you remember, we're going to do tether await. I say tether dot deployed. And now if we call tether, we see that tether is there and we know it's tether. We can verify this. Okay, so we have the right address, but I believe we actually did not compile we forgot to compile and migrate. So why don't we run a compile and make sure that we didn't make any mistakes with our contract. So let's do truffle compile. And I forgot to actually migrate as well. Please forgive me, it's Monday morning. So let's go back to another instance in your console and run truffle compile. This is outside of the truffle console. Okay, so we see we actually have an error over here. So the error is a parsing error, project /src/ contracts not found. And this is in the central bank Solidity contract. So let's take a look actually what I did here. Okay, so I just noticed my error. Do you notice it too? Well, we can't just import RWD. We have to specify the type. So this is .sol. This should be .sol as well. Okay, so this is one of these pretty little big mistakes. It's a little mistake, but it also has a big consequence. All right, so let's go back to the terminal and run the truffle compile, see that we have no mistakes. Can't believe I said that we're going to do this, and then we didn't even do it. All right, let's go ahead and do it now. Okay, so it looks like we've successfully compiled. Okay, so we fixed that mistake. Now let's run a migrate for our contracts, and we're going to use the reset flag to update the addresses. So let's go ahead and do that. Okay, so it looks like we're getting another error over here. And we see that it's a deployment failed over the central bank contract. But it looks like the other contracts worked all right. So let's go ahead one more time and take a look again at the decentral contract. Okay, so there's another mistake that I made. Well, you see in my decentral bank, you see under the decentral bank deploy contract over here, I created a variable decentral bank. And I set that to the central bank deployed. So I wanted to wait for it to deploy first. And then we run this transfer, right? And we wait for this transfer to happen as well. And we want to transfer the million tokens to our decentral bank address, right? And these are the million reward tokens. But when I'm transferring it, I'm not actually transferring it to our variable that's waited for the decentral bank to deploy, but to the actual decentral bank address. And since this isn't awaiting, it's not actually probably getting the address correctly because of the synchronous nature of JavaScript. Therefore, it's not working. I mean, that's what I see. So the mistake here, all of that can just be translated into, oh, this should have been lowercase, essentially. So hopefully that makes sense. If not, listen, I just made an error here. I didn't set the variable up correctly. So I'm going to save that. And the final thing that we can't forget to do here is we want to add the reward.address. This is in our deploy contracts, and the tether.address. So first we're going to run truffle compile. Okay, so let's do truffle migrate -- reset. All right, so looks like it works now. Awesome. So we see that we have our contracts here. We even had some gas fee being used. So if we check in Ganesh, we're going to see that our first account took a balance there. They took about 0.11 ETH. So it's not chump change. And I'm just happy that it works, that we fixed the problem over there. Okay. So now we're going to go back to the console. What we want to do is actually restart the console. So exit the console. You can exit with .exit and then just go back into it. So let's restart. We're just resetting it. Truffle console. We're back in the development. So let's give this another shot. Let's go tether is going to equal await tether.deployed. And now if we run tether.name, okay, it looks like it's working now. Phew. So we got the mock tether token. Excellent. So now we've set up our tether. So if you remember, we want to grab our account information, and we do that using Web3, right? So remember, we set up accounts to equal Web3. We want it in ETH, and then we run the get accounts, okay, function. Okay, and there are all of our accounts. We can see the 10 accounts right there lined up. These are the same accounts that we have in Ganache. And so we receive the accounts. What we want to do, of course, is here we can't forget to put await, so we can fetch them that way one at a time using a promise. All right, so now if we grab the first account, we'll actually get the account. What I did before is I didn't put the await, and instead it just ran through quickly and just returned what all the accounts were. When I ran it like this, we see that it's not even necessarily going to work. But when we run the await accounts, now we can grab any account. So if I grab the second account, it ends in A47B7. And if I check on Ganache, A47B7. Okay, excellent. So now we have the account. We're using async await, and we also see that our tether is now working. So the next thing we need to do is let's check out the balance and see if we can grab the balance, like we said, not through Ganache, but through the code that we built by interacting on the blockchain. So we're going to set up a balance over here, and let's do it with tether. So we're going to say await tether. And what are we going to put after tether, do you think? Well, we're going to use our tether smart contract, and we're going to use a function. And we could actually use the balance of function that we built, and I'll show you how that works after. And then which balance of do we want? Well, we want to grab it from our accounts, right? And let's say we want to grab the account of the investor. So that would be the second account, if you remember, for what we are building here. So then we just type in accounts and we put the array to 1, right? Let's hit enter. We get this undefined returned. But now if I type in balance, you see that we're getting a BN. And if I turn the balance, oops, and I have to remember to call it to string. All right, there we go. So now we see the balance of the account. Okay, amazing. So we're actually interacting with the blockchain now, and we're able to receive the balance of, but I would rather see this number as a million than as one with 18 zeros, right? Because remember, this is supposed to be a million ETH. We're supposed to have a million tokens. So what we can actually do is we can leverage Way to match our tether tokenomics, because Ethereum actually has 18 decimals as well. And we can use Way here, and basically Way, if you remember, we discussed it, one Way is equal to 1 over to 18, whatever that would be, 18 ETH, right? So, or 1 ETH is equal to 118 blah, blah, blah Way, right? So knowing that, we can actually run a conversion and run the same conversion using Way to get our rewards, because they also have an 18 to 18 ratio. So it's a 1-to-1 ratio. And hopefully that makes a bit more sense now. It makes a bit more sense now since we've gone over it a couple times. But if not, you can just go back to where we were building out the smart contract and check out the explanation again. we're going to have a converted balance here. So we're going to convert balance, grab it from Web3, we'll use the utilities, and we can use the function from way. Okay, and then we can, what would we put in the input here? What do you think we should be putting in here? Well, we want to convert this, and what is this? Well, this is balance, right? So we would write balance. And there we go, 100, perfect. So now we've converted it to 100, and we're going to use this as, and the other reason why I wanted to show you this now is that this is going to be an important helper function when we're building out our code, because we don't want to constantly be rewriting this over and over again. So I just wanted to show you this conversion and the formatting of it and the importance of it, especially when you're working with Ethereum way, or you're working with cryptocurrencies that generally have a lot of decimal places running next to them, right? And so we've seen from way, but there's also to way as well. So these are essentially just functions from Web3 from their utilities that we can just call to convert. It makes our life easier. So for example, let's say that we had 15 way and we wanted to convert it. Sorry, let's say we had 15 Ethereum and we want to convert this to way. How would we go about doing that? Well, we can just leverage these Web3 utilities. So we could say web3.utils.toWay. And here we can actually express the amount. So we can say 15 and comma, and then we want this in Ether. Let's run this. Oh, and sorry, this should be passed as a string as well. And here we go. So now we've got 15 converted to way. We've got the 15 with the 18 decimals after. Oh, let's just close that. Okay, awesome. So this really seems to all be checking out. We're able to grab the balance. We're able to see that everything's been deployed correctly. All of our setup is done. It's really time for us to now build out the digital bank. And if some of this stuff is still a little bit unclear, like you're wondering, for example, well, what is this tether.balance of accounts? Before we end this video, let's just go back in the code and connect these dots for you one last time. So when we were fetching this tether.balance of accounts, right? The tether, if you remember, comes from our deploying of our tether contract, right? And then essentially the accounts come from the Ethereum account from our Ganache, right? Over here. And then finally, our balance comes from the balance of function that we wrote. So if we go back in the code, we can see already here in the deployed contracts that we have our tether from artifacts required tether, and that we deploy our tether over here. So we get it. We await for the smart contract to be deployed. Right here is the tether. And if we scroll down on tether, we see that balance of was mapped out when we wrote it, if you remember. So we did a mapping. And we set up our balance to be the total supply of the person that's connecting with the contract. Okay, so that's where our balance of comes from over here. 1 million tokens, right? And that's why when we fetch the balance and we turn it and we convert it to a string, we see that the balance is 100. And you can say, well, hold on. 100, isn't it supposed to be a million? And I can say, yes, it's supposed to be a million. 1 million is the total supply, but remember that we're getting it from the first account, and the first account is supposed to be the account of the investor. And if you remember, what we did in our code is where we deploy our contracts, we automatically, the first thing that we do when these come up, the automatic first response in the deployment is to actually transfer 100 mock tokens to the account, the first account, which is the user, the customer, the investor. So they get that 100, and that's why we see 100. And that's why we see 100 in the accounts. So that was just a step-by-step rundown of what we did and why exactly we did each thing. So hopefully that's clear now. So hopefully that's pretty clear now. If not, just feel free to go through it. It's okay if you're totally new to this, and it's okay if you're totally new to this, that it could take some time. If you're getting it, that's awesome. Our setup is working. When you're ready, whenever you're ready, let's move on to the next video where we're going to actually start to build out our decentral bank together and start running some proper tests, just like you would see in the real world with assertions and using mock. And using Mocha. Sorry, not mock. Using the Mocha framework. Okay, awesome. Great work. Okay, see you in the next video. Bye.